Hi, let's continue our discussion on exploratory data analysis. And in this video, I'll be covering the part 2 of the retail data exploration that we're doing. And today we'll be mainly focusing on the data aggregation on different levels, and we will also learn how to join tables. So if you recall, we have one features table, one sales, and then one stores pandas data frame. And the first thing we want to look at how the temperature looks like in the features table. So again, we haven't talked a lot about the features table, but if you look at the features table, we have store, then date, and then temperature, So let's look at how the temperature looks like at the location of the store. Although there is no mention about the exact location of this store. So one thing we can try, can we guess which part of the country the store is located from the data that we have? So we are actually plotting the temperature graph for store ID 1, and as you can see that because we have data for multiple years, 2010 to 2013, and you have a yearly pattern, quite usual because you have high temperature at the June, July, and then the lowest temperature in January, and you have a repeated pattern because we are looking at data for multiple years, So this graph can only be useful when we plot two stores, So let's say I'm taking store 1 and 2, and let's look at the graphs. So here we see that the patterns are quite similar. So one thing we can infer that we are talking about the stores in terms of whether they are closely located, We don't know the physical location. Let's try another pair. So the store 1 and store 45. And now we see that the two graphs on the y-axis apart from one another, compared to the previous graph that we have seen. So what we can infer, at least to a certain extent, that the blue located in a comparatively warmer location than the red one, You can go a little bit more deeper, How? You see, like we have a yearly pattern. If you are given the yearly temperature pattern for the geolocations, I think we'll be able to closely extract what is the geolocation of the store, So again, here we are trying to actually get some information from whatever data is given to us, okay? Now we have already looked at partly the stores table data, and one thing we have to know that what are the different types of stores, and we found that there are 3 types of stores, A, B, and C, and A is the largest one and the C being the smallest one, okay? Now we want to answer another question. What is the average monthly sales of a store type, So let's print here sales head, okay? So if you see in the sales table, we have store ID and then weekly sales. And we have seen in our last notebook and presentations that if you take a sum or average for store, then we can tell that what is the average sales maybe at the year level or monthly level of a particular store. But here I am asking, can you tell what is the average monthly sales of a store type? Because here we only have the store information. In the sales table, we have store ID and then sales. And in the stores table, you have the store ID and type. We cannot directly get that information from the sales table. The only way we can get it, we have to actually join these tables. So to do that, we have to learn how to join tables. For those guys who have background in databases, already aware of how to join tables, here we'll be doing the same using pandas data frame. Now we'll explain the database table joins. So when we'll be referring to database table joins, this is synonymous to pandas data frame joins. So pandas data frame and database tables have similar concepts. Okay. So there are a few different joins. The first one is what we call the inner joins. When we'll be talking about joins, we will be joining as a pair, so table A and B. So if you have, like, let's say 3 tables, you will be pairing A and B, or A and C, and then the other one B and C, or C and A. And when we're doing the join, we have to have a common key. So for example, in our case, we'll be looking at where the store ID is our common key. When we're doing the inner join, after the join operation, we'll only have the records that are common in both tables. So if A is our sales table and B is our stores table, then after the join, we'll only have records where both tables contain the store IDs, So we'll see through example. And this is a left join. So left join means you will have some records in the A table with corresponding store IDs, and in the B table you will have some data with its own store IDs, but you will end up with information with all the keys that are in the A table. Even the records are not available in table B. So for example, let's say table A has record for store ID A and B, and B table has store ID just for A, but after the join you will have record for both A and B. The record with store ID B will have null values due to this join operation. Okay, and this is vice versa. So you will keep all the records with all the store IDs in the B table, even you don't have like information in table A. And the fuller join is or outer join is that you have all the records for which you have store IDs in table A and also in table B. We'll see through examples. Okay, so now let's go back to the presentation where we were. The stores table has a column store, which is also common in the sales table, sales table, then store. Okay, so we will use this key to do the joins. There are a few ways you can join using pandas. One is the join operation, and also they have a merge operation. The merge operation is more versatile because it allows us to specify column beside index, because the other one you have to always keep track of your index. Here I'm doing a join between table stores and sales, so, and then I'm just storing in a new table store sales, and I'm doing join by the store column because the store columns are common between stores and the sales table, as you have seen before. And here we are doing an inner join, so the whole idea is that we only want to include the records where you have store IDs common in sales and stores table, So let's run this, and you see that the stores has like 45 records. The sales has about 420,000 records, and if you see the join table has same number of records because we are lucky that all the store IDs that were available in the stores table and the sales table had at least one record in both tables. The interesting thing is that after we join, we found in the store sales table we have 2 more columns coming. If you look at the content, so you see these 3 columns are actually coming from the stores table. We can verify. So you see the stores table has store type and size. So in the join table we have store type and size, and then these 4 columns are coming from the sales table, and we have a common column that is a store. So that's why we have 7 columns. 3 columns in the stores table, 5 columns in the sales table, and in the join table you have 7 columns because 1 column is common between these tables. We can do this left join and right join, but for this particular case, the results won't change because we have at least one record for each store ID in both the stores and sales table. But moving forward, we'll be seeing some cases where the records actually change, and I will explain why the joins are important, and you have to correctly select what kind of join you want, For this particular case, because we want to actually get all the records that are common between these two tables, that's why we will be preferring the inner join. Okay. I think as we have got all the information in one table, so we can do much more query. For example, the questions that I posted earlier, that okay, I want to get an average weekly sales per store type, So now as we have this store type available in the join table, and we have weekly sales, so the idea is quite straightforward. So you group by type and then aggregate and take the mean, And you can see the A type store is selling around 20,000 units, whereas the store type C is selling less than 10,000, Now we can ask many more questions. For example, average monthly sales of store types. You have to do a little bit additional processing that will let you to estimate from this table, average monthly sales of store types, So here we did it weekly on the weekly level, but here the question is for the month level, One additional item we'll be learning, which we call concatenation of data. If you apply the PD concat and parameterize by your data frames, for this particular case, we're just copying it 2 times to just see like how the concatenation is working. If you put x is equal to 0, this will do a vertical concatenation. That means that you are actually adding records, The stores table has 45 records and 3 columns, and we are copying 2 times the same data frame. And if you run this, you see that, okay, I have 45 times 2, that means 90 records, but the number of columns still remain the same, okay? The format of the data frame didn't change, only we have like multiple records being added, okay? If you the other way, like if you put x is equal to 1, then what happens? You will end up with like the same number of records, but you are actually copying your column. The size of the data frame becomes 45 and 6 columns. Let's look at what the contents, and you see that store ID, type, and size. Then you get again store ID, type, and size. You are actually copying columns here. This is not a practical example. This will only be interesting when contents coming from multiple tables. So that concludes the second and the last part of our EDA. We had 2 goals. One is that we learn a little bit the retail domain, and the other, and which one is more important, is that we were doing how to do aggregation at column level, and we also covered how to do joins in between tables. So feel free to reach out to me or ask me if you have any questions. Thank you.